The views, thoughts, and opinions expressed in the podcast belong solely to the hosts and not the host's past, present, or future employers. Hello, everybody. Welcome back. It's Brian for Breaking Down Security. You do not hear or will not be hearing Miss Berlin and Mr. Betcher this week. I've given them the week off. Mr. Betcher's spending some time with his kids and his fam, and so is Miss Berlin. So, as I've said previously, family comes first, and it's nice and summery outside. So, why not spend that time doing that? So, we do have an interview this week. I'm going to go ahead and get started. It is Bradley Spengler, who, for those of you who don't know, and you'll find out soon, works with grsec, which is the a Linux implementation. So I just want to welcome Bradley to the show.
Yeah, thank you.
Cool. All right, so Bradley, everybody has an interesting background, an interesting place of where they got to. Maybe you could tell us a little bit about how you got to where you are in not just information security, but as a Linux kernel developer.
Yeah, sure. So it all started back in high school, actually. I went to a school where there was a requirement that every student had to have their own laptop and internet access and everything. It was kind of interesting at the time, pretty new at the time. So I had like a Toshiba 220 CDS, I think, 16 megs of RAM, 133 megahertz processor. And so at the time, I was kind of playing around with installing Linux and that sort of thing. And we didn't have programming classes or anything at the school. So I kind of taught myself that as well. I was already sort of interested in security at the time, but I just sort of downloaded the Linux kernel source and just started reading it, and through that and through some other work that I had done in high school, learned how to program in C, that sort of thing. I was interested in OpenWall at the time, which existed then. I think it was for the 2.2 kernels, and they were saying that they weren't going to support 2.4. And so my, one of the early things that I did was to try to port OpenWall to a 2.4 kernel. And so from there, that's how grsecurity sort of started. And then around the same time in, I think it was like October, November of 2000, that's when PAX, the page exec part of it, was announced, doing basically a non-execute bit, but prior to that support existing in hardware. And so when I saw that, I was blown away, as was everybody else at the time, because it was kind of a big deal. Everybody's talking about shellcode, and then suddenly there's this thing comes around that, shellcode is basically no more because of it. Mm-hmm. And so I had contacted that guy, Pipatch from Hungary, and I said, hey, this stuff you're doing is great. I'd like to include it in grsecurity. And then that's how our relationship started, and we've been working together since then for the past 20 years now.
Cool. Okay. So grsecurity are they kernel extensions that you can add to a custom kernel, or a kernel to make it more secure, or is it a kernel in its own right that is maintained by your organization?
It's sort of the latter. So it's basically a large patch. The patch is about 10 megabytes in size, where it's modifying basically all over the kernel on all the architectures that we support. So not only source level changes, future additions, but also the addition of large number of compiler plugins that we've developed. So, not only is the code changing, but when you're compiling the kernel, it will automatically use the plugins that we developed, and it'll uh, basically embed some additional security throughout the compiled binary.
Okay. Now, something, and we'll get to the talk because I wanted to do, I definitely wanted to discuss that. Your and the kernel patches that you're creating are not free, which is, and I'm not trying to create any controversy, but there are some people that believe that that's very controversial. There's numerous discussions online about it. Um, it this is a paid product that people can get from you. Yes.
Right. Yeah. Yeah. So it's no different from, Red Hat has subscriptions. People pay for Red Hat. It's the same basic deal.
Okay.
People pay Red Hat because they want the support from Red Hat. It's about the additional services that they provide versus just getting the source code. And that's what we
Cool.
provide to customers as a source code
Right.
of grsecurity.
Okay. And something I did not realize until I heard your talk with, there's actually five what they consider long-term release kernels. Does GRSec handle all five of those, or does it only handle certain ones?
Right. Yeah. So no, we try to keep it to about two stable kernels. Sometimes we will support three at a time, and that's just to uh, handle customers transitioning from an older stable kernel to a newer one. So that there's a couple months of overlap. But yeah, currently we're supporting the 4.14 and the 5.4
Okay.
stable kernel. So we we don't support all of them just because one, we want to keep the quality high, and as you are claiming to support additional stable kernels, unless you're adding additional resources to actually support them, the quality just ends up going down, which is what we see with the upstream stable kernels.
Okay. Yeah, I'm looking at the kernel.org page, and I was like, I don't know why there's a 4.14 and a 4.19 and a 4.4 and a 4.9, and it just seems like those are very minor changes, but there must be some jiggery puggery that I don't understand as a layman here. I'm sure you understand all the nuances there, and to be honest, we could probably spend several hours talking about the various nuances and why that is the way it is.
Yeah.
I learned several things during this discussion. Uh, the let me see. I said so. All of the vulnerabilities, because you mentioned all the backporting is causing problems. It's like developers work on, I'm assuming, the latest greatest version, which is the 5.x kernel, and then
Right.
vulnerability comes out. Built like I don't know, one that most people remember in the InfoSec community was like Dirty Cow. So
Yeah.
Dirty Cow gets a vulnerability. The kernel devs find it, they fix the vulnerability, and then they have to backport all of that to the various active, stable, long-term support kernels. And the further back you go, obviously, the harder it is to do. And you'd mentioned in the talk that one of the currently supported kernels has a lot of issues. And it's not really doesn't have all the latest patches, so it's actually out of parity with the other four more supported kernels. Why is that kernel still being supported if it doesn't have all of the necessary backported patches and fixes?
That is a good question.
Oh,
Yeah,
is
I'm
that a
not.
is that a political issue? Because I'm finding out a lot of Linux stuff is very political.
Yeah, I'm not sure. Yeah, I'm not sure why. Yeah, it's claimed to be supported, but clearly it's not as supported as the newer ones. Yeah, my issue is with that was just that it took a year for it to be mentioned at all that like important security fixes were missing on the 4.4 kernel, which was at that time it was still in pretty wide use.
Hmm.
Um, yeah,
Has
so I'm
has
not sure.
anything changed since you've given this talk about the 4.4 kernel at all?
So I did check yesterday, I think, and the syscaller feeds for 4.4 and 4.9 are still showing as broken. There was I did check also, you would think all the stable kernels should have like a syscaller feed, and there apparently isn't one for the latest LTS release 5.4. They still haven't created one for that. So actually, the only 5.x kernel that has syscaller coverage upstream, at least, is just the very latest Linux release.
Right. Okay. So you said the LTS kernels moved from 2 years to 6 years in support. Why is that a thing? Because we have people on who talk about software development and DevSecOps, and the idea of something being supported for 6 years these days is incredibly. It's like they don't believe in 6 years ago. By the time 6 years has passed, it's been completely rewritten, or it's no longer in support, or it's been supplanted by some new technology or new stack. Why is the Linux kernel 4.4 still supported? Is there a reason for that? A real reason?
Yeah, so it seemed to be primarily for phone vendors. I'm not sure what phones are still using 4.4 kernel. It may
Okay.
have been mentioned in there. So there was a Project Treble presentation. That's where this got announced. So like a Google presentation. And it may have been mentioned in there why they
Okay.
were moving to 6 years specifically. But I think it had to do with, the life cycle for some of the devices was, 2 years is definitely too short for my, I think the lifetime for them is at least 3 years or something like that. Um, and if you had it at exactly 3 years, then um, it kind of reduced the amount of switching to a new kernel that you would have to do.
Mm-hmm. Okay. Yeah, I mean the phone manufacturers make sense, I guess, if you've got a phone that isn't a Pixel or something like that, an Android phone, then that could be potentially why, I would imagine. But okay.
Yeah. There's also some external projects for supporting Linux kernels for even longer. So that I think the
Mm.
one is uh, it might be LTSI or something like that, mainly for automotive and critical infrastructure use. And I think they're claiming to support the kernels for 10 years or something like that. So yeah,
Wow.
any kind of problems that exist for LTS would exist doubly for that.
Right. Yeah, ecosystem-wide collaborative project. We maintain long-term kernel support for an industry that contains additional features such as cutting-edge device support. Yeah, so they're on 4.14.75, so they're not even on 4.4. So that's interesting. Okay. I posted links in the show notes to Project Treble and LTSI for those of you who are following along. So you mentioned something called syscaller. Could you explain what that is to the layman?
Yeah, sure. So syscaller is a fuzzer. It works on Linux. The BSDs, I think people have gotten it working for Windows as well. And the idea is to use some instrumentation in the kernel to get some idea of what code paths have been reached, and try to get execution flow into not previously reached areas of the kernel,
Hmm.
so that you can kind of exercise the full functionality, and expose vulnerabilities and other bugs that may exist. So it does this by using a number of sanitizers. So that's the KSON, KMSON, that sort of thing. So that's additional instrumentation provided by the compiler. So you can see, if there's some memory load, it will check against some special table to see, hey, was this load from some allocation that was just freed, like is this a valid memory access or not?
Hmm.
And so then it can detect certain vulnerabilities that way, where if you were to do it on a normal system without that additional instrumentation, you might, those vulnerabilities might not expose themselves.
Okay. And this is it's a static analysis tool, so you just run your code against it, or is it a dynamic?
No, it's dynamic. Yeah.
Okay.
Yeah.
Okay.
So uh, it works as basically you have a dashboard, and syscaller will start up a number of VMs uh, in with QEMU and KVM, and then uh, I believe it like uploads a little executor binary in there that tries to do the fuzzing, and then it collects the logs from the system, and based off of that, you get your reports on what bugs it found, that sort of thing.
Okay.
So
So
like as soon as the kernel will, generate a warning or a bug or any other kind of crash, it'll stop execution, collect all the information, add it to a report on the dashboard, and then you can see like, okay, we were able to trigger this vulnerability, 100 times in the past day. So you know that, hey, okay, this vulnerability is really easy to reach if it was able to trigger it this many times. Another big thing about syscaller is that it doesn't just give you these reports, which could make it difficult to try to figure out what the cause of the bug or the vulnerability was. But in many cases, it can actually generate a C file that is a usable reproducer for the vulnerability.
okay. This was on slide 27. So if you're following along on the PDF, there was KSON, KMSON, KCSON, KCOVE enabled comparisons. You had mentioned in the audio that you asked the question: is syscaller improving code quality, or is it just making people lazier and more reliant on a tool to check code? Is there some expectation that people are actually reviewing the code before these things go into commit? Is there a requirement for the developers to have it reviewed by somebody, or are they writing the code, reviewing it, saying yeah it's good, and then uploading it? What's the process for getting these patches put into the Linux kernel?
Yeah, so that's one of the issues that exists. There's not really a standard single answer to that question.
Mm,
So, uh, you know, the way Linux is organized, the development is organized. You've got Linux at the top, and then there are a number of maintainers for different subsystems, and those maintainers can have totally different rules for um, what changes they'll accept and what format they'll accept it. There's one maintainer who still doesn't use Git, who's still using email to manage all of his stuff. Um, there's the networking maintainer doesn't want people to use stable tags to notify the stable maintainer of something that needs backported. That maintainer will creates like his own list of things that should be backported to stable. Um,
hmm.
the it's generally recommended to get some reviews for some code, but how many people need to review it, and uh, uh, how deeply it was reviewed. There's no way really of knowing. Somebody could just take a look at the diff context that was posted to a mailing list and say that they reviewed it based off of that. So that's one thing that's a problem, because we see a number of examples where it's clear that nobody looked at the the patch in its real context when it was applied. They were just looking at some patch on the mailing list, which didn't have enough context to see that, hey, there's this bug here. And, if there was one additional line of context, it would have been super obvious that, that there was a bug. Yeah, so it was just things like that. Yeah. Certain people get, maybe they get some bonus or something based off of number of patches that they have they're reviewed by. for. So there might be some incentive there to have their name on a bunch of patches that they didn't really review that deeply.
Hmm. Okay. Is it a reputation-based thing? So people expect if it came from specific people, then it's probably good enough code, or is it is it just kind of Wild West still?
Yeah, it does seem like that's the case there. There's so for instance, Alviro is a maintainer of the virtual file system uh, subsystem. And he can get away with a lot of things that other developers can't. He does commits that have single line commit messages that don't describe what the change was at all. He can get changes in without any external review. Uh, so that there, a lot of it is based off of trust, basically.
Okay. Yeah, I'm just I, I'm listening to this, and I've talked to people who work in like development shops, and a lot of this stuff sounds like that would be poor, coding practice, but it seems de rigueur for Linux. So, my question was, and in slide 29, you mentioned in the audio that you use syscaller. So, if it's is it either improving the code quality, or is it making people lazier and more reliant on tool to check code? Why do you use it?
So we use it because we're doing our own independent backports to the stable kernels that we support.
Okay.
And so for the same reasons that upstream should be using it for those stable kernels, we use it so to find for instance, uh, a month ago, yeah, I guess it was a month ago now, there was a change introduced to the 4.14 kernel that caused a warning every time the system booted, just by having KVM enabled in the kernel. And because we had this is caller testing and automated uh, testing in general, we caught that the same day. We did a root cause analysis and fixed it. But upstream apparently didn't have this kind of testing in place. And so it still actually isn't fixed in the 4.14 upstream LTS. There have been about three, I think, stable kernel updates since then, and it wasn't fixed in any of them. People reported it to them, and nothing got done with it. But yeah, for us, it's just part of our QA process. So we're always we have actually a machine that's dedicated to syscaller fuzzing. It's a Epic 2 256 logical CPU system,
Okay.
just going 24/7 fuzzing. And then we have our own additions to the kernel that can generate some reports. So we have a plugin called Size Overflow, and we use syscaller to help find vulnerabilities found by that as well.
Right. Okay. It seems like KVM's causing a lot of issues. I mean, just doing a simple Google search, Linux kernel crash v KVM enabled, there's a number of bugs, some all the way back to 2009 about kernel crashing with KVM virtual machines. Enabling KVM causes any Linux VM to reboot on startup. I mean, some of these, well, here's one from 21 May that might be the pass-through bug generates bug kernel null pointer dereference and crashes. So, I mean, there's a number of issues, and it doesn't seem like that's a regular thing. So, is there a QA or a QC section in Linux, or is that just deemed not cool enough to actually have? And what is their function and role in the organization if it exists?
Yeah, so there kind of is. It's sort of spread out among a bunch of different companies. So Intel, for instance, has like I think they call it like the O-Day tester bot or something like that, that does some sort of testing, like compile testing, maybe some boot testing for changes that go into Linux. A newer one is kernelci.org, which I think is trying to be like the go-to place for the continuous integration testing for the kernel. So they're trying to sort of combine all the other testing efforts. So getting LTP in there. There's talk about using um, so I mentioned earlier about how syscaller generates the C files that can trigger vulnerabilities that it discovered. Well, an idea for regression testing is to take all those C files and use them as regression tests. So to verify that, hey, this vulnerability was actually fixed. Um, so there's that going on. Kernel CI is somewhat recent, but it seems like more so than previous attempts at doing this, of which there have been many. It seems like there's a bit more motivation behind this one. So
Okay.
it does seem like it's advancing pretty quickly.
Right. So during your talk on one of your slides, you said exploitation trends that attackers still don't care about whether a vulnerability has a CVE assigned or not. I fully agree with that. I think some attackers don't care if it has a CVE. I'm thinking from the lines of bad guys because they don't want a CVE attached to their vulnerability. They want it to keep hidden.
Yeah.
It's a. I said don't. So my thing was don't. Are there any do you know of any direct kernel vulnerabilities that do not require somebody to go through an application first?
So it kind of depends on the context. So, say in like a web hosting environment. So there it's a different story because anybody with a compromised credit card basically now has local access to your system. And if it's like a shared web hosting, of which that used to be the main thing. Now I guess it's sort of phasing out a bit, but it still exists. Um, now they have access to the same kernel that dozens or hundreds of other businesses on the same machine
Mm-hmm.
are dependent upon. So if you compromise the kernel, now you have access to everybody else's information on that server.
Right.
So there's an issue, um, with the security of PHP and web applications, that sort of thing. Um, you know, it's generally the case that if that sort of stuff is present, somebody will eventually have local access to that system. But yeah, you do need, outside of those cases, you would need some application level vulnerability.
Right. Yeah, I was doing some more research before we got started because my thought was, and you had mentioned this in your talk that Zerodium gives out bounties for people who have found bugs, whether it be at Pwn to Own or if they're just a security researcher and they can't get their voices heard by the Linux mailing lists or whatever. They buy those vulnerabilities and do God knows what. But they have a graphic, and it's in our show notes. Plus, there's a link to it talking about what's the payout for that, and it's up to $100,000, I believe, for currently, according to Zerodium's website in their little table of periodic vulnerabilities or whatever. Linux LPE is up to 50K, but they did say, according to a 2018 article, up to $500,000, depending on the type of chain needed, or I'm assuming it's all in context. But do you believe that what would be something that would be considered really bad? Would it be like a bad packet that would allow for an overflow to cause RCE? I mean, what would be a $500,000 vulnerability for a Linux kernel?
Yeah. So about the 500,000, I'm not. I tried looking into it based off of that article, and I don't see that there was anything saying that they would give away 500,000 for a Linux kernel bug. I think it
Yeah,
was kind of they were kind of talking about like Linux in general, as in like uh, GNU Linux sort of versus the Linux kernel,
yeah, I think
because like the what was it, the highest payout that they were listing for uh, desktop server systems was an Apache RCE,
Right.
for 150,000, and then back in 2018 for a Linux kernel local privilege escalation, it was only 30,000 for it.
Yeah.
Um, but yeah, I mean the worst thing in the Linux kernel would be you know uh, some type of wormable, internet accessible vulnerability in like the networking stack or something like that.
Yeah, yeah. There was a white source software that talked about top 10 vulnerabilities, and like the first couple were, send a bad UDP packet, and you've got them. It's in 2016. There's number one was in 2017. Um, my yeah, I'm just trying to figure out if the reason they price them so low is because they're kind of a link in the chain, or you don't really, once you have root based on, let's say you're running an unpatched WordPress, once you get root on that box, you don't have a need to do anything with the kernel. Um, uh, I mean, so my question is, we're spending a lot of time, and you at GRSec are spending a lot of time adding security to the kernel, and people are adding this stuff. To what end what's the end game here for y'all with regards to your Linux kernel security stuff? If the applications are where it's at.
Um, yeah, so to go back to what you mentioned earlier, I think the pricing of it has to do with who their customers are. So you
Mm.
can see it's kind of they're paying a lot for mobile related stuff, which maybe gives a clue into who's paying for these exploits. But it's also a numbers game of I imagine that they have a lot of Linux kernel exploits. Um, already on hand. And so they're just not paying that much for it. I think in 2018, they were paying about the same for Linux local privilege escalation as they would for Windows. And in Windows, like local privilege escalations are pretty common. I don't think they really care about them as much as Linux does actually.
Yeah. Yeah,
Um,
yeah, I was just thinking, would it be fair saying, root and persistence is all that matters, and you don't need to worry about the kernel to do so? I mean, if you can gain access to the kernel, are there other things that you can do that you can't do when you have root or persistence on a box?
yeah. So, in the day of SE Linux and that sort of thing, it does actually matter being able to get access to the kernel because all the security on the system depends on the integrity of the kernel. If you compromise the kernel, you can disable SE Linux. You can disable it in like a sneaky way where it looks like it's enabled, but it's not really.
Mm-hmm.
You can temporarily turn off auditing of what's happening on the system. So any kind of behavioral monitoring tools, that sort of thing, none of those work anymore. Um, yeah, so it's important in that context because generally without a kernel compromise, you're not going to you know get outside of what's defined in a SE Linux policy or something like that.
Mm.
The other angle is that generally for any kind of hypervisor escape, most of the time that will require kernel access to start with.
Okay.
So it still is pretty important.
Okay. Yeah, I'm obviously I was thinking too small there, and while you were sitting here, saying that, I was also thinking about other ways that it could have been. I mean, you get a lot of embedded systems. I mean, we just talked to Shlomi Oberman, for the last 2 weeks, talking about the Ripple 20 and the custom TCP stacks that are used in potentially billions of devices. Those often have plug-ins to small embedded Linux kernels as well.
Yeah.
If if I'm an embedded Linux, developer or somebody creating an IoT device, is GRC sec something that I could put on an IoT device or inside of my Tesla that I own that's in my garage right now? Could I put those things, put your custom kernel on my system without having any kind of issues, and would that enhance the security of those? That's kind of rhetorical, I would imagine, but
Yeah.
what's the overhead on something like adding another 10 meg to a kernel?
So the 10 meg is just the size of the patch. It's not going to affect the binary size necessarily. It's not going to increase the binary by 10 megs or whatever. Uh,
Okay.
yeah, it can definitely, the size of the Linux kernel itself when it's unpacked is, yeah, I don't know, hundreds of megabytes, maybe probably even a gigabyte or two or something like that.
That's
Um,
awfully large for the Linux
yeah,
kernel. I mean,
well, a lot of drivers, and there's still the drivers for like ISDN, um,
ah,
a bunch of ancient stuff that's not even used anymore. So that's all in there.
okay.
Um, but yeah, you can definitely use it in embedded environments. We support ARM, ARM64, MIPS, PowerPC. So yeah, we have customers using it for embedded devices. So.
Hey everyone, Rachel Toback here, Chair of the Board for Women in Security and Privacy, also known as WISP. And I want to tell you about an opportunity to get involved in the community. On Friday, June 26th, the security community came together to lift and amplify the stories and work of Black security and privacy practitioners on Twitter and LinkedIn through the hashtag Share the Mic in Cyber campaign, which was organized by Camille Stewart and Lauren Zabarick. In response to this campaign, we started raising funds for Najla, who was my partner in the campaign, also known as 4Sci_Q on Twitter, to sit for the PMP, OSCP, and CISSP. We ended up raising the $2,000 to cover Najla's expenses, and we're now moving on to cover as many training, certification, and learning or advancement expenses as possible, incurred by Black security and privacy practitioners in the Share the Mic in Cyber group. As of right now, on July 6th, we have $16,000 raised and about $26,000 in needs for the community. Please consider a donation or a corporate sponsorship to cover these expenses. You can head on over to tinyurl.com/sharewisp for our donation page, or you can go on our Twitter page @wisp.org so you can see the full donation link yourself. You're security-minded, probably want to see the full URL. I get it. Thanks so much for taking action, and I'll see you on the internet.
Okay. All right. So the other thought I was thinking, because we talked about this before we started recording, was that adding all of these things, adding ASLR, CASLR, the mitigations against Meltdown Inspector. There was some discussion a few years back when it was the new hotness. Adding these things would cause performance hits. It would cause later on it was found that it was mostly in network throughput, or if you were doing, I believe it was a lot of high input output kind of stuff on the processor. I don't know. I'm sure you
Yeah.
can help set me straight on that. But is adding all of the security stuff, because you had mentioned several of these things have a very low adoption rate or no adoption rate at all. I think CII was one of the ones that had come up, and I don't know what that is, so we'll ask what CII is in a minute. Are they not being implemented because there's no use case for them? Are they not being implemented because developers don't know how to use them properly? Are they being not implemented because they actually hurt or get in the way of what developers are trying to do?
Um, there's a little bit of each. So, one of the major reasons is that these security features get added to the latest Linux kernel release, but what distributions are shipping, at least like Red Hat, CentOS, the kernel version is much older.
Hmm.
So it's not new enough to be able to take advantage of those new things unless they specifically backported it to their older kernel. I think Ubuntu now is shipping some newer kernel versions, so it can take advantage of some more of that. Um, Part of the Another thing is that the feature kind of has to be designed for a distribution in mind, so that the feature can be enabled by the user or disabled by the user. And ideally, when the feature is disabled, it shouldn't contribute any additional performance hit to the system.
Hmm.
But I think things like PTI, replenes are pretty commonly used these days, except maybe for, if you have a development system or something like that, which, isn't interacting with the rest of the world. It just kind of gets, some code pushed to it or something like that. In those cases, if performance is super critical on those systems, and people might disable PTI, repleans, that sort of thing. The reason for, a security feature not being adopted, it just kind of has to do with, it not being designed for distribution. So, for instance, the one that I talked about in the presentation, the static user mode helper, I don't think that one got adoption because it required some user land changes. So if you want the feature to be adopted, just make it kind of work, automatically, which is what we try to do with the features that we provide.
Okay, so you said some changes had to be made to user land. That's a very big place with a lot of applications. When people are thinking of these security changes, how hard is it to? I imagine it's hard enough just to be a kernel developer, but for somebody who's created something security minded, how do they market the security feature to make it so that it is important? Do they all eventually get added and then never used, or I don't follow the mailing lists, but I have followed OpenBSD's miscellaneous list for a few years, and I do know that sometimes people will suggest things and it will get a lot of, that's dumb, we're not going to do that, not just by Theo, but from other folks or other developers. What's the how do you prove that something is actually needed and needs to be implemented in there, or is it just a one-off case when they put those up?
So how the kernel kind of advertises those new things, it's mostly by a series of blogs by Case Cook. He does one for each kernel version, security things in whatever the kernel version is. If there are important changes, it'll also be mentioned on kernelnewbies.org. They do like a similar sort of write-up, but for like all the changes that go into a particular kernel release, like the major changes there. But outside of that, there's not really much in the way of communication. So like if you're thinking, trying to compare to the reports that Microsoft's Research Center, MSRC, puts out. So like they did one recently regarding some variable initialization stuff that they did. Nice multi-page report, explains how to use the new feature, all this kind of thing. That doesn't really, exist at that level of quality for Linux, which, you could argue maybe that contributes to lack of adoption, but the main thing is that, the people who would mostly be adopting it would be the distributions, and you have to assume that they're pretty clued into Linux kernel development, that if some security feature comes along and it makes sense to adopt it, then they'll adopt it for their distribution.
Okay. Is kernel security implementation largely based on a reactionary approach? So, we've got the next dirty cow or Heartbleed or something that comes along. Oh my God, we need to create another widget to add to the kernel that does, no exec, like you talked about. No exec was one of the biggest things that happened. And I remember using OpenBSD when they were talking about that in the main list and all the issues that would cause. Ultimately, it was added because it was secure. Is kernel security additions largely a reactionary thing, or is it a proactive thing?
I would say mostly reactive upstream with a little bit of proactive. So on our end, since 2003, we've had a document on the PAX website, paxfuture.txt, that described basically like a categorization of vulnerabilities and exploit primitives. And so we have an idea of like, okay, this feature took care of, shell code. This one takes care of code reuse, ROP, all that sort of thing. And so now we're working on data-only attacks. So like any kind of memory corruption-based attack that you can think of would fall into one of the categories that we've come up with.
Okay. And I was thinking along the lines of proactive would be like maybe a customer ask. I mean, you are creating a custom, kernel configuration kind of thing. So if you had a customer come to you, hey, I want to be able to do X. I'm a, ICS SCADA company. I need to be able to do this. Could you develop that and push it out, or is it just something specific? And do you actually at GRC have security things that are added to the kernel that normal Linux kernel folks don't have?
Oh, yeah, of course.
Okay.
Yeah. I mean, from our end, we're pretty far ahead of what is the state of the art elsewhere. Like, we've been focusing on securing the kernel from the kernel since 2003, which back then, there were a few people doing kernel exploits at the time, like the isec.pl people, a few others, but it wasn't really mainstream, which it seemed to get more mainstream around like 2009 timeframe for the Linux kernel. So we've just been working on it for a long time. So we have a lot of tricks that aren't found elsewhere. So for instance, like CFI, we've had the first and most secure CFI implementation for the Linux kernel since 2015 was when we first announced it. And they're just now sort of getting CFI into the upstream Linux kernel based off of some LLVM implementation.
Mm-hmm. Yeah, I could imagine. I mean, not just with security, but changing your compilers from GCC to LLVM was also causing a lot of consternation because there's additional compile flags, additional methods by which you can securely generate that code or optimize it properly. Comes with its own level of issues because some things just won't compile in LLVM that does in GCC. I was looking through some of the questions at the bottom here to see if there was anything we could discuss. Somebody had asked, where was it? If you disable as many config options, have you actually reduced your attack surface, or is this the most vulnerable code not in modules? Maybe you could, explain that.
Yeah, sure. So generally, if you care about security of your system, it is a good idea to build your own kernel instead of using the one provided by the distribution, because the distribution is trying to appeal to everyone. It's not appealing to your specific use case. So, you may have no need for, 80% of the features that are included in a distribution kernel. And by building your own kernel and disabling the options that aren't going to be used, you're reducing the attack surface of the kernel. A lot of vulnerabilities exist in things that nobody had any clue that was actually in the kernel. Like some TTY LDisk driver, which gets auto-loaded by an unprivileged user. This thing nobody knew existed. Now,
right.
It's granting access to the kernel because there's a vulnerability in some part that, nobody knew about.
Right.
So if you can custom compile it, you can deal with that sort of thing.
Yeah, it reminds me of the, the CIS benchmarks or the STIG benchmarks for the U.S. military. It was like you have to disable certain file systems from loading, so JFFS and SquashFS, and I'm like, I don't use those. Nobody uses those. Why are you wanting me to disable them? And, they're not even enabled in this kernel, but I have to have a config file that says they're automatically disabled in case somebody tries to go into it. It's kind of stupid, but I can understand why the need to do that, but I don't...
Well, another reason for that is so there's a tool called udisks, which can be present in desktop environments, and that will let an unprivileged user, say you plug in a USB stick into the system, well, it's going to auto mount whatever file system is present on that USB stick, which could be, one of these file systems that nobody really would ever use, and it's specially crafted just to, uh, exploit some property of the kernel or something like that.
Yeah. Yeah, well, I need my CD 9660 FS. I need to be able to mount CD-ROMs and stuff. So, I can. No, I completely understand the need to remove those config files, but the problem is there are so many, and you remove one, and all of a sudden you can't boot your system, or it really takes time and effort to pare that down. So, and completely understand if you've got a vulnerability out there and you can say emphatically, yes, we've disabled the config for that, it doesn't even load that, so we're not vulnerable, that would be great. But with the number of configs on there, I mean, that's I would say several hundred hours worth of work for maybe very little return, and at least in my opinion. Depends on, if you're running an embedded system or an IoT system, you'd want to disable as much as you could to save on space. If you're, especially during compile time, if you're creating a custom kernel, or you're trying to save space in your RAM, because like you said, it's about a couple gigabytes. So if you've only got so much space, then that makes a lot of sense. So
we also have a feature in grsecurity that prevents unprivileged user from auto-loading modules. So you could get the same attack surface reduction just by converting as much stuff as possible from built-in to as a module. And then if some process running as root needs that capability, it's able to auto-load the module for that. But an unprivileged user won't be able to load some module that otherwise wouldn't be used on the system, just for exploitation purposes.
Right on. Let me see. I think the only thing I wanted to go through real quick was during your talk as well, you had mentioned that somebody would take and put something up on the mailing list, and instead of asking where their threat model was, they'd say, hey, did you run it through something else, or your white space is off, or something like that, real neckbeardy kind of stuff. And I was wondering how you do a threat model for a security feature in a kernel. What's the first question that you're asking, and what does a threat model for a kernel like? Because I do threat models for individual systems or whole computer network systems, or whole computer environments. What does a security module threat model look like? And where do you start with that, and where does it go in the life cycle of your creation?
Sure. Yeah. So the first thing that you would start with is is the feature designed against local attacks, remote attacks? What type of capability are we assuming about the attacker? What sort of vulnerability do they have at their disposal? Something like KASLR, it would assume that there's no information leak in the kernel. So when you start actually thinking about the threat model for a particular feature, it'll kind of clue you in as to whether, is this thing going to be bypassed all the time, or is this going to be a strong security feature? So the more you assume about the attacker's ability, and the security feature still performs, meets its security goals under that model, and that's going to be a much more secure feature. So something like KSLR assumes that there's no information leaks. We know that there are tons of information leaks in the kernel. They're found all the time. And so because of that, the experience with that feature has been what you would predict from the threat modeling, that, it's just going to get bypassed all the time, because every time you have an information leak, you have a KSLR bypass.
Okay.
So similar thing with the lockdown mode. It's there's not really. I tried looking in the kernel configuration help to see if there's any like threat model or anything discussed in there, but there's nothing in there. It's just basically like, if you enable this option, it'll disable some features that grant access to certain parts of the kernel that shouldn't be allowed under a secure boot scenario. But then there was like a bypass for it, which disabled the option via loading a malicious ACPI table. So then that got fixed, but there's just going to be a bunch of similar issues. And then not even that, but the Linux kernel developers don't really care about privilege escalation if it's like a root to kernel privilege escalation. So
right.
Yeah, it's a bit of security theater to think that well, it's not even clear what it's trying to do. So that's why threat models help.
Yeah, well, see, so a lot of InfoSec people thrive on, methodology and having a standardized way of doing something, but it sounds like there's no standardized way of doing a threat model. Not trying to be passive aggressive here, but it seems like the folks on the mailing list who ask for a threat model, maybe they don't even know how to do a threat model themselves. I'm just trying to figure out if there was a way of doing that. So that might be another show. I don't know. I'll have to talk to some of my friends in the threat modeling world to see if there's something for that. Maybe my friend Mr. Cowan would like to come on the show at some point. I'm going to tell him about this show, so hopefully he'll be able to poke around a little bit.
Sure.
Cool. I think I'm almost done. Was there anything else you'd like to mention or discuss? We can talk a little bit about what the conference is about since I'd never heard of it before, but was there anything you wanted to discuss before we kind of wrap up the show? It's your platform, so,
Oh, yeah. No, I would just, like to say that, you guys pointed out a lot that, we're hating on Linux kernel developers, that sort of thing. But we greatly appreciate the work that Linux kernel developers do. It's very impressive, all of what has been able to be accomplished in Linux kernel from everybody contributing to it, that sort of thing. But it's just that, I'm complaining because what I do is, Linux kernel security. I don't do, I don't work on the scheduler. So I'm not talking about, how great the scheduler is. I'm not doing the networking code to talk about how great the networking code is. My focus is just on security. And so,
right.
Yeah, so that's just why I talk about the security of Linux.
Yeah, no, I have a lot of respect for the folks running the Linux kernel as well. I always thought it was kind of magical. First Linux I ever touched was Slackware 7 for something that I was doing with the Navy that I can't talk about. And I got these two guys coming from Hascom Air Base, and they gave me this disk, and they're like, "Oh, we're installing this on a server." And I was like, "Well, what is it?" And they're like, "Well, this is Slackware, it's Linux." And I was like, "Really? Oh man, where can I get a copy?" And they gave me the disk, and they were like, "Here." And I was like, "Wait, what? This is you? I can have this?" They're like, "Yeah, it's free. You can just download it anywhere." And I was like, "Oh, that's pretty badass." And it was dial-up, so it would have taken me forever, but I appreciate them doing that. And that kind of got me on the bug of learning that. And then I went to OpenBSD and learned how they do things, and they treat, code quality and, documentation. So, I've seen a lot of it. It seems like that kernel thing is kind of complicated, and there's a lot of moving parts there. So I do appreciate that. So, so the Linux Security Conference Northwest, let me get it right because I don't want to screw it up. I did mention them in the tweet. Linux Security Summit North America. Yeah. Where was this located in? Other than in North America, but.
So the one that was, they initially announced this one in February, I think, and it was originally planned to be in person in Austin, Texas, before all the COVID stuff happened. So then it switched to virtual conference.
Does it rotate, or is it always in Austin? Because I used to live in Austin, so I was right under my nose for 4 years and didn't know about it, or is it just a rotating?
No, I think it rotates. The first one was in Boston. So I haven't really kept track of where it's been in the years since, but I think it moves around.
Right on.
And then they also have like a Europe one as well.
Oh, okay, that makes sense. All right. So yeah, I tweeted them out today that I was going to be talking to you since you were a speaker there. You can check them out on their Twitter feed or find them online. I'll have a link in the show notes to the Linux Security Summit, so you can check that out. Seems like it was more academic kind of atmosphere than say like a ShmooCon or DerbyCon or like a typical InfoSec conference. Am I wrong in that thinking?
Yeah, I would say it's probably more formal than what you would see at like a ShmooCon or something like that.
Okay.
Yeah, less less fun, less sarcastic. Yeah, all that type of stuff.
Okay. Do they get together and do is there Hack Fest, or is there any hacking, like hackathons or anything going on while they're there, or is it just a bunch of talks?
The one that I went to in Boston, there wasn't really. It was actually I was surprised because I was thinking okay, I'm going to show up in person at this conference, and like the developers that should hear this message would be there. But it was basically, a few dozen people in a small room was like the entirety of the conference, and none of like the major developers were in there. It was basically, the people working on the security subsystem of Linux presenting to each other for the most part.
Okay. Well, hopefully next year all this COVID stuff will be over with, and we'll be able to get back to meet space conferences. I know Black Hat and DEF CON are going on in a couple of weeks, and they're going to be all virtual. So yeah, that's awesome. Okay. So Brad, just to wrap up here, if people wanted to talk about all things Linux kernel or GRC or PAX or any of the other things, or maybe they are hearing about this custom Linux kernel, configuration utility that you've got, and they want to, get in, it's not get involved because it's not an open source project, but if they wanted to maybe buy it or talk to you about it, how would they find you?
Yeah, just go to grsecurity.net. And there's a contact form to get in touch with us.
Okay, very cool. All right. That was it for Breaking Down Security this week. Thank you again, Brad, for coming on. And if you ever get any ideas for, additional things that you'd like to talk about with the Linux kernel, we could do a deep dive. We could maybe talk about Linux configurations in more depth or something like that. I'd love that. And thank you for coming.
Yeah. Thank you very much.
Right on.
That was our show for this week. You can find show notes for this and all of our shows at www.breakingsecurity.com. You can also find an RSS link on the site to add to your favorite podcatcher. You can find all of us on Twitter. Miss Berlin can be found at InfoSyster, INFOSYSTIR. Mr. Betcher can be found at BetcherPwned, BOETTCHERPWNED. And you can follow me on Twitter at Brian Brake, BRYANBRAKE. We have a Slack. Come join us on our Slack. A lot of great things going on there. A lot of channels of various InfoSec-related subjects. You can get an invite on Twitter by emailing our official Twitter handle for the show at Brakesec, BRAKESEC, or you can email us at bds.podcast@gmail.com. Thank you to all of our Patreon supporters for their monetary assistance by offsetting costs involved in putting out a weekly show. Zoom fees, Libsyn hosting, domain purchase, renewal, equipment upgrades, time and effort building the community we have. We appreciate all of your help and support. If you'd like a t-shirt, stickers, coffee mug, or just to show your support for the show, you can check out our TPub site, www.tpublic.com/user/BDS podcast. We thrive on your feedback. A quick 5-star comment on iTunes or Google Play Store or your favorite streaming service, Spotify, Pandora, what have you, go a long way to gaining us additional visibility. It takes no time at all, and we appreciate your help in spreading the word. That was it for Breaking Down Security this week. Be safe, be well, be kind to one another, take care of yourself because you're the only you have, and we'll talk to you again soon.